Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our systems of equations and systems of linear inequalities. And more specifically today, we are going to expand from our equations to our inequalities. So at this point, we should understand that a system is formed by taking two or more equations or inequalities and creating one big math problem out of it, where you're looking for the solutions that satisfy everything in that system. So when you have equations, the solution is going to be the point or location that satisfies both problems, or maybe all three problems or all four problems. We focused on only having two equations, but you could have systems with 3 or 4 lines, and you're still looking for that individual location or point that works for all lines in the system. So for today, we're going to expand that to, well, how does that change when we have linear inequalities instead of equations? And the thing that's different about equations and inequalities is with equations, it's a line of solutions. Remember, with your inequalities, it could be a boundary line and a section of a coordinate plane that is solutions. So for your solution of a system of linear inequalities, you're looking for the section of the coordinate plane that works for both parts of the system. So you have to go through your graphing linear inequality work for both lines. Please remember that means I'm doing work for the boundary line and testing to see where to shade for both lines. So these are a little bit more complex, a little bit more work to do. So go ahead and take a second, fill in your blanks so that you understand how to go through and do your graphing linear inequality work, which is reviewed from earlier in the chapter. And then how to find that place, that region of your coordinate plane where they overlap one another, right? That's the section that is the solution to the entire system. So be careful. All right, some things I need to remember about inequalities is if the inequality could be equal to, then we'll use a solid boundary line, which represents that that section of the graph is part of the solutions. If there's not an equal to, then we need to use a dashed or open line. So your process here is exactly the same as your equations. When we have inequalities, right? So we have two problems that create one big system. We need to graph them individually, and then we only keep the shaded section where they overlap or it works for both. So your first time through, you want to make sure that you're doing things very super light and faint, because it's not your final answer until you find the solutions that work to both. So let's start with our first. Y is less than or equal to -3. Remember, for your boundary, you want to make that an equals. So we want to graph the boundary line of y equals -3. That's a special case. So let's make a quick little table where our y's are always -3. And our x is -1, 0, 1, and 2. Right? Those are the ones we've been using. Now, since this could be equal to, our boundary line is going to be solid. So down at -3, right, these are the points we just did. We're going to have a solid boundary line. All right, now, if that were an equation, we'd be done. We'd go to the second line, but this is an inequality. So remember, we need to test a point to know, right, should we be shading above here or below here for this first line? Now, once you find out where you should shade, you're not going to really shade. You're just going to very, 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 very lightly put some marks so you know where you would have shaded. So I'm going to test 0, 0. So in our y is less than or equal to -3, this is the y. So substituted in. 0, is it less than or equal to -3? All right, that doesn't work. 0 is not less than or equal to -3. So what you want to do is super lightly, down here is the part where we would shade. I'm just going to real super light, just kind of put some X's down here so that I have them to reference. That's where we shaded for the first one. So what we want to do is now we want to go through that process for the second line and see where would we shade for that second line and find where they're on top of each other. Because remember, the solutions where I color has to work for both problems. So let's go to our second part, right? That's how much we have so far, right? A solid line at -4, and everything below it could potentially be where we color it. All right, this second part of our system is in slope-intercept form once we put in our equal to. So y equals 4x plus 1. So we have a slope of 4 over 1, or -4 over -1, and a y-intercept of 1, or 0, 1. All right, so let's start. Maybe I should go, I'm going to go to a different color here. That'll help us a little bit. All right, so up 1, and then from there, up 4 over 1, up 4 over 1, or we can go down over 1, down 2, 3. And we're no longer really worried about where they intersect necessarily. Now be careful, this is a greater than, it's not equal to, so this second line has to be dashed. So there's a lot going on here we have to think about. Just be careful when you connect here. This should end up being a dashed line. All right, now, when we go to test, right, we're going to test to see if we shade on this side or this side. If this is the side we shade, then this, like down here, right, where the red X is, will be where we keep. Right? That's where they would overlap. If this side is where we shade, then this section here, below the red and to the right of the blue, is where we would keep. So we have to run our test to see where's that final, graph. Where are we going to finally shade in the end? All right, so I'm going to erase these things that we don't need here. I'll go ahead and put in that red X we had down here. Okay. All right, so y is greater than 4x plus 1. 0, 0 is not on our line, so we can go ahead and use it. 0, is it greater than 4 times 0 plus 1? So 0, is it greater than 0 plus 1? Now, 0 is not bigger than 1, so that doesn't work. So where we would shade for our blue line, I'll go ahead and put some X's out here, would be on this side. Everybody see it? Okay. So we're looking for where there's red and blue, which is this bottom corner down here. That's where they overlap. That is the only section we will keep. So when we go to do our shading, all these old X's, right, we need to do them so faintly or get rid of them because they're not part of our solutions. And our solutions then should just be this bottom corner down here. Right? That's where we would shade in. And so we would end up with something that looks like this. So when you're working on Google Slides, for the shaded part down here, you would just do some line segments down here like that. So I know you know the final section, right? We have 1, 2, 3, 4 sections created. Show me you understand it was this one down here, this number 3. All right, let's try another. Number 2. I want to solve this system that's created with the 2 linear inequalities. 2y minus 5x is less than or equal to -4, and 4y minus 2x is greater than or equal to 8. All right, let's start with that top one. I'm going to put in our equal sign. So 2y minus 5x equals -4. All right, we have standard form. I'm going to go slope-intercept, but we could use intercepts here. Where we have 2y minus 5x. We're going to add 5x equals -4 plus 5x. Be careful, this is backwards standard form, so we're used to the x term being in the front. We still need to get rid of this subtract 5x part first by adding 5x. I'm going to bring this plus 5x to the front. So we're starting to build that mx plus b format. All right, let's go through, divide everything by 2. So y equals 5 halves. Needs to stay as 5 halves because it's our slope. So no mixed numbers there, like no 2.5 or 2 1/2. Slope needs to be one big simplified fraction. And then our y-intercept here of -2. All right, we could do plus -2 if you want to see that. All right, so we're going down at -2. And then from there, we're going to rise up 5, run out 2. So 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. Or we could go down 5 to the left too. So down 1, 2, 3, 4, 5 over 2. All right, this line could be equal to, or this graph could be equal to our line. So when we connect, it's going to be solid. Just make sure you're really thinking about that as you go. All right, let's test a point. Do we want to be to the left of our line or to the right of our line to start with our shading? 0, 0 is not on our line, so I'm going to go ahead and use that one. Remember, the rule is if this point works, I color it. All right, and now for right now, I'm going to put little X's there because it might not be the total region we're ending up shading, because for the system problem, we have to find where they overlap. So 0 minus 0, is it less than or equal to -4? 0, is it less than or equal to -4? Nope. All right, so 0, 0 doesn't work, so I don't want to shade it for this blue line. So just real light, I'm going to go in and maybe I should make that even lighter. All right, real light. I'm going to go in here. This is the section we would have shaded. All right, so we're halfway done. Now we want to figure out where that second boundary would go and where we would shade for it so that we know where to keep the overlapping, which is the solution to the entire system. All right, so I'm going to switch here. I guess that's in red, so I'll stay in blue. So our second equation here that we're working with is 4y minus 2x equals 8. All right, again, it's in standard form. We can do intercepts or slope intercept, but I'm going to go ahead and do slope intercept. So 4y minus 2x plus 2x equals our 8 plus 2x. To get 4y equals, I'm going to bring this plus 2x to the front and the plus 8 to the back. So we have our mx plus b order going on over there. And then divide through by our 4. All right, cancel. Y equals 2 fourths simplifies to 1/2 x, and 8 fourths simplifies to 2. All right, so you have a slope of 1/2, or we could use -1 over -2, and a y-intercept of 2, or it's the location 0.2. So we're going to start at 0.2, or excuse me, 0,2. And then from there, rise up 1, run out 2. 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 And we can do the same thing. Drop 1, go left 2 until we run out of space. Go in this direction. All right, this could be equal to again. So we're going to have a solid line. All right, now I'm going to put numbers up here again. 1, 2, 3, and 4. So when we run our second test down here to see where to shade for the blue line, the only places where we might end up actually shading is in section 2 or section 3. Because right now, 1 and 4, right, this section is going to be out, this section is going to be out. So if we shade down from the blue line, right, if we shade down here, section 3 is our answer. If we shade up from the blue line right up here, then section 2, right, this red X, there's a red X up here where 2 is. I'll add another one in there so we can see, right, this little red X here is really up here, right? It's this whole section right here, right? So this section's out, and we're looking to see if it's 2 or 3. All right, so I'm going to go ahead and just clean it. We know it's not this. We know it's not this. All right, so is it section 2 or 3 when we're done here? All right, so let's run our check. 4y minus 2x is greater than or equal to 8, and 0, 0 is not on our boundary, so I'm going to go ahead and use it. So 4 times 0 minus 2 times 0, is it greater than or equal to 8? Multiplies first, so 0 minus 0 would give us a number bigger than or equal to 8. No, sorry. All right, 0 is not bigger than 8, so this doesn't work. I can't color it, which means I should be shading above, right? We're going to shade this way, which means we would shade this whole side, including here where the red is. So our final graph is just that section 2, right? Just this wedge in here on forever. And so our final graph would look like so. two solid lines, and then what I call the wedge number 2 up there would be our final solutions. Again, if you're working on your computer, just make sure you put some line segments in this section to show me that's where you should be keeping your final solutions. All right, example number 3. We want to solve the system of linear inequalities 2x plus 5y is less than or equal to 5 and 6x plus 2y is less than 4 using the graphing method. So let's start with that top one. 2x plus 5y is less than or equal to 5. Put in your equal sign. That's what you need to do your boundary line. I'm going slope-intercept form again here so I can graph a bunch of points. But you could use intercepts because it's in standard form. Those both would be fairly simple and easy to use. I'm going to flip-flop my order so I have that y equals mx plus b format starting to happen over there. All right, we're going to divide both sides by 5. So y equals negative 2/5 x plus 1. So we have a slope of negative 2 over 5, or we could use 2 over negative 5. And a y-intercept of 1. All right. Since it could be equal to, our line's going to be solid when we go to graph here. So rise up, or sorry, drop 2, run out 5. Drop 2, run out 5. Or up 2 to the left 5. Up to left 5. All right. Now we can connect with our solid line. All right, 0, 0 is not on our boundary, so we can use it to test to see if it's a solution. Remember, the rule is if this point works, we would color it in. It's a solution. So that's where we're going to, that's the side of the line. In this case, we would put some X's on just to help us get a little bit organized as far as where we might end up shading our final solution. So 2 times 0 is 0, plus 5 times 0 is 0. So when we do 0 plus 0, will we get something less than or equal to 5? Well, yeah, we sure do. 0 is less than or equal to 5. So 0, 0 is a solution. So I'm going to add some X's, right? This is the side, right? We would have shaded it down here, all right? Now, I'm doing that so faintly that I can either go back and erase it or you won't pay attention to it in the final graph, so be careful. All right, so let's add in our second line, our second boundary line, and our second set of shading and see where we would end up shading our final solutions to the entire system. All right, so put your equal sign in. Again, I'm going to go slope-intercept form here, but you could use intercepts because it's in standard form. Flip-flop your order here. Negative 6x plus 4 starts to get you in that y equals mx plus b order. Then we're going to divide through by our 2. Make sure everything's getting divided by 2, not just the 4, not just the negative 6. So y equals negative 3x plus 2. All right, so we have a slope here of negative 3 over 1, or we can use 3 over negative 1 and a y-intercept of 2, which is the point 0, 2. So up 2, and then down 1, 2, 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, or up 3 over 1, up 3 over 1, and so on. All right, now this is not equal to, so this is going to be dashed. Be careful when connecting. The points are just helping you draw in the line. We're not too worried about the actual dots. They just help us connect where our dashed line goes. All right, now, when I'm looking here, if we end up shading here to the right of our blue line, then this section, we'll call it number 1, is our answer. If we start shading on this side of the blue line, then over here in section 2 is our answer. This section 3 is not a possibility. We didn't shade there for red. And this section 4 is not a possibility because we didn't shade there for red. So it's either going to be this bottom right or bottom left wedge. So let's test our point. 0, 0 here is not on our boundary again. So let's use it. 6x plus 2y less than 4. And we're going to test 0, 0. So 6 times 0 plus 2 times 0. Would that give us something that's less than 4 is the question. Multiplies before adds always when following PEMDAS. So 0, is it less than 4? It sure is. which means we would shade on this side of the blue line, which means section 2 will be our winner, right? All the other sections shouldn't have nothing in them. They should be completely clean, and section 2 should be getting our final coloring or shading, and it will end up looking something like this. Again, if you're working on like a Google slide or on your computer, just down here in this bottom corner, just give me some, give me some line segments down here, like so, to show me that you understood that it was that section of your graph. All right, I hope that helps you attack your work for today. See you guys later.